All right, hello once again. This is Jeff Scott, formerly of Rankin Technical College, and as part of my YouTube channel, which you can see on the screen, JPS-Jeff Teaches Programming, and in particular, part of the YouTube playlist, Jeff Teaches Programming-Python. What I previously did was I gave an introductory lecture on object-oriented programming, and I'm going to add to that right now by going over the thing that's right here. It's called OpenPython Guide to Key Terms and Concepts Part 1, which implies to me that there'll be additional parts. But it only came out about 10 or 12 days ago, so we'll see. And as it says, it's got some essential terms of object-oriented programming in Python. All right, so let's just take it from the top. Object-oriented programming, also known as OOP, is a programming paradigm. Now, what a paradigm basically, in my opinion, means it's kind of a change in thinking. All right, and OOP, as it says there, uses objects, which are instances of classes, and classes, which are blueprints, to create models based on the real world. It simplifies complex software development problems by breaking them down into smaller pieces. So, in this first article, as the author says, they will explore some fundamental object-oriented programming concepts. I'm not going to read them. You can see them right here. As it says, this foundation will set the stage for exploring advanced topics in future articles. All right, so if I take it from the top, now, I'm going to disagree with this. All right, what do I mean? I want to show you exactly what I'm talking about here. Let me do it here. All right. Python is a high-level object-oriented programming language. And I'm going to tell you that I disagree with that. But I think that's true. Now, what do I mean by this? Who cares, etc.? Just to tell you real quick, if something is object-oriented, in my opinion, it means that you're basically required to use objects, classes, etc. in all your programming. The Java programming language is an example of this. Now, I've gone through several lectures. This is my 27th or 26th or 28th, I don't know, in this program that I'm creating. And I've never used classes until the last lecture. To say something is object-based means that you have object-oriented functionality which you may or may not choose to use. So again, in my humble opinion, Python is a high-level object-based programming language rather than a high-level object-oriented programming language. Am I splitting hairs? If you say I am, okay. Again, you already mentioned this, but at its core, any object-oriented programming language is a paradigm shift in thinking that helps structure and manage complex code bases by modeling real-world entities using classes and objects. In object-oriented programming, a class is a template or a blueprint. An object is an instance of a class. Objects contain attributes, which I've called properties, and some people would disagree with the use of the word properties there. We can stick with attributes, that's fine, or data. And methods. Methods are functions that exist inside of objects or inside of classes. Okay? So here are the terms that they're going to go over in this article, and notice there's a dozen of them. Some of these we've already touched on. Function, arguments, parameters, methods, attributes, encapsulation, abstraction, composition, inheritance, aggregation, overriding methods, and polymorphism. And again, some of these we discussed and went over in the last lecture. All right. So functions, arguments, and parameters. A function, as it says, is a block of code designed ideally to perform one specific task. As it says, it's defined using the def keyword and can be called to execute a class. Functions are self-contained. You can use them without classes and without objects. That's what we did prior to the last lecture. They can return a value. Oftentimes they do. I wouldn't say typically. I'd say often they return a value. So let's start with this one. So I'm going to come in here, and I'm going to create a new folder. And that new folder is going to be called, I'm going to put this in there, it's going to be called OOP in Python Part 1. Okay, so that's going to be the name of this. Alrighty. And let's create the first thing in here. So we'll create a new file. We'll call this function.py. Okay. And I'm going to come in and just grab the code that's in here, paste it in, and let's look at it before we call it. Okay. Now, this is the function right here. So functions are defined starting with the word def for define, the name of the function, a set of parentheses which may or may not include arguments, or also known as parameters. This is the body of the function. So this is the function. It's called greet. And if I call greet and I pass Assad, it should say hello Assad. Well, let's change that and let's put my name in here. All right, so file, save all, and let's run this. And you can see when I do, I get hello Jeffrey Paul Scott. Okay, so this is the function. This is the function invocation. Or the function call, whatever you want to call it. All right. That's the function. There's the name. There's the parameter list. There's the function body. And there's the function invocation. So call, also known as invoke the function. Okay. Hopefully, at least that makes sense. We've talked about that for quite a while already. Nothing really new there. All right, let's go on. Arguments and parameters. Parameters, as it says, are variables listed inside the parentheses. So again, there it is, right there. They receive values when the function is called, and they're placeholders for the actual values that are passed. It says arguments are the actual values passed. A lot of books disagree with this stuff, just so you know. So here's another one. Let's take this one and let's put it in here, but we've already got something called greet right there. Okay, so what I'm going to do is I'm going to come in here and I'm going to make greet 2, where you have to pass in both a name and an age. All right, and then we'll invoke it just like we did. All right. So this one, we'll just say Jeff, but we need to also put an age in here. So this one should say, hello, Jeff. Oops, I guess it was there. You are 67 years old. All right, that's what it should say. So let's see if indeed that's the case. We'll keep the first one in there. All right, now it doesn't like. It says it takes one argument and two were given. Well, is that the case? Oh, this has got to be greet 2. I'm sorry, because that's what we called it up here. So let's fix that. Save all and run it again. Let's clear this and run it. So we get our first one. Hello, Jeffrey Paul Scott. That's the invocation of function of greet. And then, hello, Jeff, you are 67 years old. That is greet 2. Okay. Again, not a whole lot of new stuff, I would say, at least in there. Methods and attributes. Now we're getting into the realm of classes. All right. So notice we're creating a class. This is the entire class right here. We are creating a class, and that class only has in it a method. Again, a method is a function defined inside of class. So this expects that we're going to pass in a name, and it'll say hello followed by that name. So let's go in here and look at this one. Let's go back into here. I think we've got enough in here already. All right, so I'll do a file, save all here. And before I get rid of it, I want to do one thing, which I forgot to do. I'm going to add this in all of these. This is exactly where I got all this stuff from. So there you go. Okay. All right. So file, save all. That's the end of the first one in here. Let's go in. We're in here in their OOP. We'll create another one. We're going to call this one person.py. Start by pasting that same thing in again. And now I'm going to grab everything that was in this article here, right there. So we're creating a class called person. This is our method. Here we could call this anything. You know, if I want, I could call this Jeff, for example. I could call it Assad. Let's put in Jeff Scott here. So the output, hopefully, now this will have to be then Jeff.greet. And hopefully it'll say, hello, Jeff Scott, if I did it right. So what's happening here? This is creating a new person object. So we've got something in memory, and it's not doing a flaming thing until we call its method. This right here is this. And all functions require the word self. So this is the method, and as it says here, there's my output. Let's see if it works. Hello, Jeff Scott. Well, there it was. There it is. All right. Again, nothing, overly difficult, I don't think, about what we've seen in here so far. All right. Attributes are variables that belong to an instance of a class. There are no attributes in the person class here. None. There's just a method. Here are some key points about attributes. All right. So let's imagine that what we put in here, let's make some changes. In fact, we'll keep our person one. All right. Let's copy this. Let's create a new file. We're going to call it person2.py. All right. And I'm going to paste this in. Now, as of right now, they're exactly the same thing. All right. But let's say that in here, we wanted first name and we wanted last name and we wanted an age. Now, right now, it's kind of screwed up. It doesn't know exactly what we want here. All right. So this greeting is going to expect all this. In fact, let's leave the greeting the way it was. Let me get rid of this. We'll just put in here self. I'm going to get rid of this. Like that. All right. And now we're going to put in here self dot. We got a class person. All right. And that person class is going to require self, first name, last name, and age. All right. Okay. Now, looks a little weird right now. It looks like it's wrong, and maybe it is. But let's just take a look at what they've got here. It is. We don't want to put anything in here. In fact, all we want is class person. Should have known that. All right, so now we're going to put in here def underscore underscore init underscore underscore, and we'll put in there this. We only need one set of parens, like that. All right, so oops. So we're going to say here for now, I want to keep this simple. So I'm going to say self dot first name equals first name. All right. Self dot last name equals last name. And self dot age is equal to age. All right, now I want to come in here and say hello, and I'm getting errors because I don't have a name anymore. So I'll say first name, space, I think I need self dot. All right, hello first name. Self dot last name. You are self dot age years old. All right, let's see if what I did was correct. Okay, so we've got person here. So now I'm going to say Jeff equal person, but I'm going to pass into that Jeff, Scott, and 67. Now I'm going to say Jeff.greet. All right? And I don't think I'm going to have to pass anything in here. If it comes out the way I'm hoping it will come out now, all right, the output then will be, hello, Jeff Scott. You are 67 years old. Like that. Let's see if that works. Or if I made one or more mistakes. Hello, Jeff Scott. You are 67 years old. Hello, Jeff Scott. You are 67 years old. So yeah, that worked. All right. Now, for now, I would say, notice what they say, attributes can be public. And if something is public, it's kind of like a public figure, meaning it is accessible to anyone and everyone. If something is private, it's only accessible within the class itself. We're going to get into this more, but for now, just so we don't have to keep using all these underscores, etc., I'm not going to do that. All right. So this is my interpretation of what they just did in there. So as it says, name and age are public because they don't have any underscores. All right. They're instance attributes, meaning each time we create a person, that person will have a name and an age. But technically, if we created 100 people, they could have 100 different names and 100 different ages. Now we have in here also occupation equal, and you'll notice that technically that's not inside of the init method here. It's outside of it. So as it says, it's a class attribute. So all instances of the class would share this. So these would be distinct for everybody. These would be shared by everybody. All right? So that's the first thing. Let's jump into the next one here, which is encapsulation. Now again, as I mentioned before, some of this stuff I talked to you about previously. Encapsulation, as it says, is when you bundle data, also known as attributes, and methods that operate on data into a single unit called a class. Yeah. And as we mentioned, this helps hide implementation details. You only have to show the person the interface and explain to them how to use it. You don't have to explain how it's implemented. It protects data from external interference, and it provides a controlled interface for accessing and modifying data. Now, oftentimes, as it's shown right here, this is done with getters and setters. I mentioned this to you before. So let's grab this. Let's copy it. Let's go into here. All right, we have person. We have person 2. Let's come in and let's make person 3. All right, I'm going to hit enter a couple times. I'm going to copy all that in. And I want to copy from here. Like I said, I'm making sure everybody can see this. So I get rid of function, person, person 2, dog, dog 2, keep person 3, and get rid of animal, anything I got open here. There we go. And I'm going to paste that in. Okay. All right. So what's different here? Well, you'll notice, just like before, all right, we've got a definite, but now we've got underscore underscore here, which means that this is private. That means the only place I can technically change the first name or the name or the age is inside of this class. So somewhere in here. So here we've got a get name and we've got a get age. There's no sets in here. So in other words, these are read-only. So if I change this to Jeff, and I change that to 67, the output here is going to be Jeff, and the output here is going to be 67. Let's verify indeed that what I just told you is correct. Jeff and 67. So there are no set methods in here. Let's make some. All right. So I'm going to grab this, copy it. Okay. And now instead of we got a get name and a get age, I'm going to make a set name and a set age. All right. So with this set age, let's say that we not only need this, but we also need a name put in here. All right, so here we'll return. I'm going to try to do it like this, self.name. And here we're going to put this in and an age, and we're going to return self.age. And again, I'm trying to at least, we'll see if this works or not. we're coming in here and we're making some setter methods. Okay. Now, doesn't seem to like this. I don't know if it is expecting an underscore there or two. All right, or just this. There we go. Okay, so big deal. Okay, well, I'm going to come in here and I'm going to call these again. So we create, so here, you already saw this. What are we doing? Instantiate a person object. That's what we're doing here. Here, we're going to invoke the getName method. There we go. Then here, we're going to invoke the setName method. Okay, I'm sorry, it's still the getName. This is the getAge. All right, then we're going to come in and we're going to, I don't even know if they showed this in the book or in the article, but I'm going to come in here and I'm going to try to invoke the setName method. All right, so we'll print in here person.setName, and I'm going to put in here well, not sure, but try doing it like this. Probably should just read ahead and it'll probably be in there. All right, I'm going to come in here and I'm going to call so let's see. I do need a name in here, I believe. We'll find out in a second. And I do need an age in here. Why? Because I need to pass something in. So for the set name, let's put in Jeffrey Paul Scott. And I'm hoping that's what the output will be. And for the age, I'll put in one more. So that would mean that the output would be 68. Now, we'll find out. I might very well be doing this incorrectly, but that's okay. Let's see. All right. So I'm invoking the set name there. And the set age method there. Let's see if it works. If I get an error, I'll just go back and read in the book and see what they say. Yeah, they don't like something in here. That's okay. The first one, yeah, of course, you would think it would work. Takes one positional argument, but two were given. Oh, that should be set, not get. My fault. So there you go. Calling it the first time, we got Jeff and 67. Then after doing the set and calling it again, we changed it from Jeff to Jeffrey Paul Scott and from 67 to 68. All right, just so you see that. Okay, let's talk abstraction. Abstraction means hiding the complex implementation details and showing only the essential features of an object. So in other words, if you look at this example, we don't need to know how the deposit method or the get balance method work. They have been abstracted from us. All right, we only have to know how to eventually call this. So let's come in here with this bank account. All right, I'm going to come back to here. I'm going to go back up to the top. I'm going to save everything. I'm going to grab this like I did before. And come in here. Let's create a new file. We're going to call this bank account. .py. Paste that in. All right. And now we'll come in and grab everything that was in this article right here. Copy. And there you go. So we have abstracted away the data, meaning what our balance is, all right, the deposit, and a getter for the balance. Now, we could come in here as an example. What if we added in here withdrawal? All right, so that would equal balance minus equal amount. Now, we're not doing any checking in there to make sure everything's all right, but I just wanted to show you that. Okay. So let's see if we can get this quickly to work in here. So let's save it. Let's close this so we got a little room. Come on. So we got a little room to work with. So let's come down here. And we'll say, what was this called again? Bank account. We'll say BA1, bank account 1, equals bank account. All right. And when we initialize it, we're supposed to give it a balance. So let's give it a balance of $1,000. Okay. All right. So let's immediately call BA dot, and we'll print it. We'll print in, let's do it in an F string, initial balance, and we're going to call in here get balance. Okay, doesn't like it, and I don't know why. It's not defined. It's defined right there. Well, I had that problem before, and I fixed it by just doing this. No, it doesn't like that. So here, let's start filling this in a little bit. So we will say here, instantiate a bank account object. Yep, that's correct. Def. Okay, so we should be setting the balance there. Initial balance. Well, how about if we do this? Well, let's see if they show it in here. I am purposely not trying to go too fast in here, just so you know. All right? And what I'm doing with some of this, if something doesn't work, part of the reason it's not working is I'm trying to use stuff I've learned in other languages. No excuse. All right? I should be a little bit more adept at some of the stuff I'm doing than I am. So let's go back. Let's go back in here and grab, doesn't matter which one, we'll grab this one. Okay, that must be it then. So this would be print BA dot get balance, or BA1, sorry. There you go. So that should say initial balance should be 1,000, if I did it right. So print initial balance. All right, file, save all. Initial balance $1,000. Okay. Deposit. Oh, let's say $567 into BA1. Okay. So that's BA1 dot deposit 567. Now I want to come in and print the new balance. So print new updated balance. So updated balance. If I did it right, this should now say 1567. So it should print 1,000 for the first one, then the updated is 1567. All right, that all worked. Let's try a withdrawal. So we'll draw $800 from our BA1. So this will be a withdrawal 800. So 1567 minus 800 should give us 767 if we did that correctly. So we'll print out the new updated balance. We'll put here after deposit, and we'll put here after withdrawal. All right, so let's try that and run it. So our initial was 1,000. We put in 567. So our updated balance after the deposit was $1567. Then we went in, we withdrew $800. So our new balance after withdrawal was $767. All appears to be working as far as I can tell. All right. Next thing that's discussed in here is composition. As they say, it's a way to combine objects or classes into more complex things in a more simple way. Notice they say it's a relationship between objects where one object owns a collection of other objects. Okay? So, for example, a university contains multiple departments. A car contains multiple wheels. All right? You wanted to look at, a couple of other ones that are not shown here. You could say, as an example, an alarm clock could technically contain a clock object. So if I made a clock object that had hours, minutes, seconds in it, and it had that I could set the time, for example, then I could make, based off of that, I could make an alarm clock that had everything from that. But I could add to it the ability to set an alarm or turn an alarm off. All right. The example they're giving is an engine. So we got a class engine and a class car. Notice that they are two distinct classes. But what I can do is I can say self.engine equals engine. So that should say engine started. All right. And I've also got a start car, which says self.engine.start, which again is going to call that. Let's see if this works. We'll come in and create another one in here. And we will call this car.py. Again, what I'm going to do in just a moment is I'm going to add that stuff that I had in here before. So let me just grab that. And let me double check. So that's in there. 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 Yep, they're all in there. Good, except for the last one I'm about to do. So that can go into car right there. So if I run this and it works, I'm creating a car object there. And what's that going to do? It's going to basically create an engine object. And then I'm calling start car, which is going to call the engine start. So it should say engine started. Let's double check and make sure again that everything that's in here works and works as we would expect it to work. Engine started. There you go. Now, their example of composition is probably better than mine. I think mine was composition. There's a few terms in here that I may screw up on, but I don't think I have. We'll see. Inheritance. Inheritance is where one class, a child or subclass, inherits properties and behaviors from another class, the superclass or parent class. The subclass inherits all the attributes and methods of the superclass and can add new attributes or methods or override, meaning they can change the ones that have been passed in. Now here's another example that they have. There's animal. All right. And a dog is a type of animal. Here we have just generic sound. Okay, we could have really put pass in there and then put bark in here. And I'm going to grab this. I'm going to use their example. So let me go in and we'll call this one animal. Animal.py. And I'm going to close a few of these. All right, bring this in here. Okay. And I'm going to bring this in from here, but I'm going to add to it a little bit. Okay. All right, so what do we have in here? Right now, if we run this, we're creating a dog, and we're calling dog.sound. So it should say bark. All right, and we're going to say the dog says bark. All right, well, let's create 2 more of these. All right, so we'll have a total of 3. The next one will be cat. And this will say the cat says meow. All right, so inheritance. So this will be the cat class. And then let's do a cow. Oops. Not a cow. All right, so the dog says bark, the cat says meow, the dog says moo. Okay, whoops, and I lost that, so there we go. All right, so let's grab this. And we've got dog equal, again, we can call this whatever we want. We can use dog, that's okay. This will be cat. And this will be cow. Good gravy. If I did this correctly, it should come in and say the dog says bark, the cat says meow, the cow says moo. And there they are. All right. All right, let's move on. All right. The next thing in here is aggregation. And this is where I might have screwed up. Let's see. Aggregation is a relationship between objects where one object owns a collection of other objects, but the contained objects can exist independently of the container. So as it says, it's a weak form of composition. The differences are shown here. Composition, contained objects cannot exist independently of a container. Aggregation, they can. So in the example here, we've got book and we've got library. All right, but a book can exist without it being in a library. It can be in a bookstore. You could have bought it, etc. So let's grab that. We'll come in here and we will add another one. There's that. Bring in this. Close that. There we go. So we've got a book class. And when you create a new book object, you have to pass in a title and an author, and they're set here. All right. Notice when you create a library, we're creating it as an aggregation. So basically, it's an empty type of list. And we can add books to it. So now we're creating 2 different books, and we're adding them to our library. Let's see if that works. So there they are. But those books, again, can, C-A-N, those books can exist outside of a library. All right. Now, overriding is when a child takes something that was passed in by the parent and changes it. As it says here, in object-oriented programming, an override method in a subclass, it's a method in a subclass that has the same name, the same return type, and the same parameter list. This is basically known as having the same signature as its parent has, but it can override or change it to, as it says here, provide a more specific implementation that differs from the parent. So here we've got this. Now this is the one we used before, but I'm going to use this one and I'm going to copy it, and there's a reason I'm doing this. All right, so shouldn't have done that, but that's fine. This will be animal 2. .py. Okay, we're going to put that in just a second. Let me get this in here. So close this. Let's put in this one. There we go. All right. Now, we can instantiate an animal. We can do that. So if I come in here and say animal equals animal, oops, it's got to be a big A. Sorry about that. And animal.sound good gravy. What I should get now in here, and let's reverse these. What we should get now is generic sound followed by bark. There it is, generic sound and bark. But what we've done is dog is a child of animal, but we overrode the sound method. So instead of saying generic sound, it now says bark. And as I showed you in the examples before, I went in and created a dog and a cat and a cow, and we overrode it every time. All right, we've got polymorphism left, and that'll be it. So polymorphism, again, it's a Greek word that means many forms. As it says, it allows methods to be used interchangeably, even though they may belong to different classes and have different implementations. There's different types of polymorphism. You can have polymorphism with methods, which we've already seen, with operators, and with functions. So if you look in here, notice that we have an area here, and we have an area here. So it's a shape, and the way you figure out the area for a circle is different than the area for that you figure out the area for or a square. They're both called area for the method name. They're both a child of shape, but the system knows to call this one when you're working with a circle and to call this one when you're working with a square. So let's prove that, and we'll put this one to rest. So we will call this one shape.py. Paste that in, and then we'll come in and we'll paste in what was shown in the article here. All right. Now, what should the output be? Let's clear this, and let's take a look before we even run it. All right. So it says we want to go through. We've got a circle and a square. All right. So a circle, we want to find out the area of with 5 being passed in a square. So this, for circle, should print what? It should be 3.14 times the radius, all right, which I think we're passing in as 5 squared. So it should be 3.14 times 25. This should be 5 squared. It should be just 25. So this will be somewhere around 80, and that should be 25, if I did it right. All right, let's check. Area of the circle is 78.5. Area of the square is 25. So it knew here which area to call based on what we gave it. The first time we're giving it a circle, the second time we're giving it a square. Now, just to show you this, I don't even know this, you know, I'm probably the wrong person to be doing this, but cube. Does the cube have an area? How to find the area of a cube? How about the area of a triangle? It's 1/2 times the base times the height. Well, I'm going to try this. Knowing me, I'll screw it up, but we'll try it anyway. All right, we're going to add to this triangle, and it'll be 5 and 5 in just a second. Don't worry, we'll fix it right now. And he'll have to put in base and height. And it'll be self.base equal base. Self.height equal height. And the area will be return area of the triangle is one half, which is 0.5, times the base times the height. Hopefully I did that right. All right. So it should say, should have now 3 outputs. Area of triangle is probably 12.5 if I did my math right. And there they are. So what I attempted to do in this second lecture that I'm doing here, so let me do a file save all, or save, and get rid of that. Go back to here. Is I attempted to go through this document right here and quickly explain to you these terms: function, arguments, parameters, methods, attributes, encapsulation, abstraction, composition, inheritance, aggregation, override methods, and polymorphism. What I plan on doing next then is to go in and rewrite the examples that I'd done before, the payroll examples. All right, but rewrite them using classes. And I'll be in to do that one next. Thanks.